Hello guys, welcome to our class for today. I hope you are doing good and that you are fine. And so far you are following our classes very attentively. So this is Normal Science Tutors Online. We are your online physics tutors, and for today we are going to be looking at AC current, that is simple AC circuits. Right? We're looking at simple AC circuits. In our last class or our last video, we treated transformers, and we give you some test your understanding to take care of. So this class will be looking at simple AC circuits, and so for today, please just get your writing materials ready so that we can go to our class. Please, if you have not subscribed to our channel, subscribe to our channel, give us a like, give us a thumbs up, and give us positive comments, right? Give us positive comment. Invite your friends too to come and enjoy what you're enjoying here on YouTube. Our aim and objective is to make you to be a better student, for you to understand physics better, right? So that's why we are breaking our classes or our lectures or topics into similar segments for easy understanding. So please, if you have your writing materials ready, we can go straight to the class. This is Normal Science Just Online, and I remain your online tutor to Michael. So if you are ready, get your writing materials, your calculators, because we're going to solve some problems. We're going to solve a lot of problems, and then just to drive home the topic, right? So if you are ready, please let's go for the class for today. Thanks. All right. So what is a simple AC, or what is an alternating current? Alternating. Once you understand that English, it becomes easier for you to also understand. Alternating is something that is like fluctuating, something that is going up and down. That is alternating, right? So an alternating circuit is a circuit in which an alternating current flows, and this current is produced by time dependent alternating voltages, right? So what you have here is an example of an alternating circuit or an AC circuit. So once you see this sign, you know that okay, the current that is flowing through this system is alternating. So if you check your circuit diagram, you will see that they always use this sign to indicate alternating current. So check your circuit diagram, you see this sign for alternating current, and then this typical alternating current that is flowing through this resistor. Then this is a voltmeter, right? That is measuring the PD across this resistor, right? So this is simple AC circuit, and for alternative voltage, the EMF that is flowing through the current generator is given by this wave equation. Now, also for alternating current, this wave equation can also be related to alternating current. Is that okay? So yeah, so the alternating current varies sinusoidally or periodically in such a way as to reverse its direction periodically. Now, what that simply means that you see this current, this is the graph of an alternating current, right? So the current moves and it gets to this point, and then it reverses back like that, and that is how it continues down. Now this is a complete circle, right? Don't forget that a complete circle is equals to what? 360 degrees. So if you remember, when we discussed simple harmonic motion, if you have not watched that video or that class, you can go back and check simple harmonic motion, right? So the current that has this characteristics is called an alternating current, right? And as I said, can be represented by this same equation can be adapted for alternating current. That is what we have here. Okay, so that is this equation that you are having here. So if you compare these two, this is EMF and this is this thing. So each of these symbols you see here, they have their meaning. Right now, this equation can also be written as this. Okay, so what you are seeing here, this is the current or instantaneous current, and this is the peak value of the current. This is sine this is a phase angle, right? This W, you know that this angular velocity, right? This is the symbol for angular velocity, and this is the time. So the product of the angular velocity at the time is called phase angle, right? It's called phase angle, and this can also be written in this form. I want you to look at, or you can go back and view our our lecture on wave equation. Okay, so if you go back and you view our lecture on wave equation, you find out that those equations, they are almost like this too, right? So this is the typical form of a wave equation. So, but this particular equation is for alternating current. That's okay. Now remember that angular velocity is equals to 2 pi f, right? I hope you remember that because I just brought this one out for easy understanding. Remember that angular velocity is equals to angular displacement all over time taken, and angular displacement is equals to 2 pi. And you don't forget that 2 pi is equals to 360 degrees, right? So this is 2 pi all over the period. And you know that the inverse of your period, or the reciprocal of a period, is equals to frequency. So that is how we got this 2 pi f. Is that okay? So there's no ambiguity here. This angular velocity that you see here is equals to 2 pi f. So by the time you substitute this 2 pi f into this, you will have this equation. So these two equations you see here, they are the same. So that's why we are this is equals to this, right? So I hope that one is understood. So as I said before, this is instantaneous current. This is a peak value of current or maximum current. That is current at this particular point. Okay, because if you look at this particular waveform, this is the peak value, this is the maximum value, and this is the minimum value, right? So the peak value of the current is given to you by that IO. Then frequency is F, okay? Then W, as I said before, is the phase angle of the current. Yeah? Then this angular velocity. Okay, so these are the meaning of the symbols for this wave equation for alternating current. Please just take note of this. So this is the wave equation for alternating current. All right, fine. Similarly too, we'll also look at the wave equation for alternating voltage. Okay, so as I said before, just as we have for alternating current, that is also how what we have for alternating voltage. So alternating voltage can be represented by these two equations. So remember this, you remember the one for current, then this is also for, so just like for the current, this is the peak voltage and this is the instantaneous voltage. Okay, so this is instantaneous voltage, and then this is the peak or maximum voltage. This is your angular velocity, and that is the time. Then this is the phase angle. All right, so these are the initial equation that you need to know when we're talking about AC circuit or AC current or AC voltage. AC is alternating current or alternating voltage, right? So just take note of that. So I gave an example here that I'm trying to explain this wave equation for you, right? So if an AC voltage is represented by this relation, the frequency of this voltage will be what? What will be the frequency of this voltage? Right, so in this particular equation, you are be given that voltage, which is instantaneous voltage, is equals to the, so what you do is that you bring in the wave equation for voltage, right? Bring in the waveform equation for voltage, and this is the equation. Now you now compare it with the equation that you are giving. Okay, so this is what you are giving, and this is the wave equation for voltage, and this is what you are giving this. So if you compare those two equations, you find out that the peak value of the voltage is equals to 4. So peak value VO is equals to 4. This is VO and this is equal to this. So this VO is equals to 4, right? Then 2 pi ft is equals to 900 pi t. Okay, so that is how you solve problems relating to this waveform equation. So they were asked to find frequency. So what you do is that you equate this part of this equation with this, because these are the two that are related. So by the time you do that, you are going to have this is what you are going to have. Now you should know that from this equation, pi we cancel out, t we cancel out. So what you have left is 2f is equals to 900. Your f will be 900 over 2. So, and that gives you this. Okay, so this is how to apply the wave equation for alternating current and wave equation for alternating voltage. Please take note of this equation, because gradually as we progresses on this topic, you come to more difficult application of this equation. So I want you to take note of them as we apply them to solve some problems. Alright, so this is basically the introduction to simple AC circuits. Right, as we go further, we're going to talk about reactance, impedance, and all that. But for now, this is the introduction to simple AC circuit and simple AC current. So having said this, I think the best thing I want us to do, we'll just also look at peak value and root mean square value of alternating currents. Peak and root mean square value of alternating current. Okay, so peak and root mean square value of alternating current. Now, as I said before, if you look at this waveform, this is the peak value. Okay, so this is the peak value of your current or voltage, because the funny thing about this is that the voltage and the current, they are moving together. Okay, so in this particular case, you can say that they are in the same phase. So they have the peak value at the same time. Okay, so this is the peak value of your current and also peak value for your voltage, as the case may be, because you are going to use the values to calculate for your root mean square value and all that. So this is the peak value, which is the maximum current or the maximum amplitude of the waveform. So the peak value of an alternating current is the maximum value of the amplitude of the AC currents or voltage in a circle. Alright, so that's what I've explained already. Then the mean square current is the root mean square current is defined root mean square r.m.s current is defined as a steady or direct current which produces the same heating effect per second in a given resistor. Okay, so for root mean square current, it is given by this equation. Root mean square current is equals to the peak current all over root 2, and the square root of, the inverse of square root 2 is equals to 0.4. You can punch that out from your calculator. Then you have 0.71 times is the peak value of the current. So you please take note of this equation. Now, this same equation, you can rewrite it as this. So that's what I have here. Okay, so root mean square current was 0.71. These values have already been derived. So this is the equation. Root mean square value is equal to 0.71 times your peak value of current, or the root or the peak value of your current is equals to square root 2 multiplied by the root mean square value of your current. So when you make this peak value the subject of this equation, you will have this. This one is equals to this. So this is equals to this. Then this one, from here you can get this. So take note of this equation. Similarly to the root mean square value of your voltage is given by the peak value of your voltage divided by root 2, and that gives you, if you should look at these two, they are almost like the same, right? So if you look at this and this, they're almost like the same. It's just the voltage that is different. So root mean square value of voltage is equal to 0.71 multiplied by peak value of voltage, or peak value of voltage is equal to square root 2 times the root mean square value of the voltage. So please guys, I need you to take note of these equations, because shortly we'll use them to solve some problems, because that is the only way you have a better understanding of what I've been discussing with you. Okay, so I think we can go straight now and then solve some problems. All right, so please get your writing materials so that we can solve some problems together, please. Okay, so this is this question says that an AC or an alternating current has a peak value of 4 amp. Calculate the root mean square current, and then 2, the current at the instant where the phase angle is equal to 60 degrees and 150 degrees. So the first thing you want to do is that you should calculate the root mean square current. Okay, so this is what we want to do first. We are going to calculate the root mean square current first. Okay, so let's, in this question you are given say you are giving, okay, so this is what you are giving in this question. You are giving the peak value of the current is what is given to you. That is IO is equals to 4 amp. That is all that is given to you in this particular question, and you are asked to find, first of all, you are asked to find r.m.s, which is the root mean square value of the current. Then you are now asked to find I, the instant current, when Wt, when the wave angle is equals to 60 degrees and 150 degrees. So these are what are given to you in this particular question. All right, I think this is a wire question. Okay, so look at the variables that you have so that you will know what you want to, which of the equations you are going to use to solve. Now you are asked to find root mean square current, and you are given the peak value. So obviously you are going to use this equation that relates the root mean square value with the peak value of current. So we have this equation, root mean square current is equals to IO all over square root 2, which is the same thing as 0.71, okay, multiplied by IO. Okay, so you can just substitute into this equation and then have your result. So we can substitute into this one. We have that root mean square value of the current, it will be equals to 0.71 multiplied by IO, which is the peak value of current, is 4. Okay, so by the time you work this out with your calculator, you have 2.84. Okay, so you have 2.84 amp as the root mean square value of the current. Okay, so the second part is that you should find the instantaneous current. Now from the wave equation, I said from this wave equation that we had, from the wave equation we have that instantaneous current is equals to the peak value of current sine angular velocity times time. Okay, so now you look at this equation and then know what value to substitute. So instantaneous current when the phase angle is equals to 60 degree is equals to, substitute into this equation, is equals to the peak value of current, which is 4, multiplied by sine 60 degrees. So if you do that, sine 60 degree is equals to 0.8660. You can check that from your calculator. So you have 4 times 0.8660. Please work that out from your calculator. So you have, if you calculate that one, you have 3.46 Okay, so in this particular instance, when the phase angle is equal to 60 degrees, your instantaneous current is equals to this. Then for the B part, when the phase angle is 150 degrees, the same equation that you will use. So I'm not going to rewrite the equation, I will just substitute the value. We already know that the peak value of current is 4. So I'll put 4 there, sine 150 degrees. Okay, so don't forget that sine 150 degrees is something as what? It's something as sine 30 degrees. Okay, so you have 4 multiplied by sine 30 degree is equal to 0.5. Alright, so by the time you work that, you are going to have 2.0 Okay, so this is the solution for this particular question. So you can see how I related the equations from the beginning down to using the wave equation to solve for the instantaneous current. That's okay. So this is how to apply the wave equation to solve some typical problems. So we'll go to other ones too. Okay, so this is another question that I want us to look at and then find solution to. This one says that the current I in an AC circuit is given by the equation this. So you are given this equation, right? Where t is the time in seconds. Deduce the following from the equation, and this is actually a WIAC theory question. Okay, this is a WIAC theory question. Okay, so in this particular question, what is given to you only is the wave equation. Okay, so what are we going to do? What I'm going to do is I will write down this wave equation. Given that you are given the AC current, AC circuit equation to be I is equals to 30 sine 100 pi t. Alright, then your normal wave equation for current is given as IO, that is peak value of current, sine WT. Now, as I said before, this equation can also be written as, because here this is a pi, this pi, you are looking at the variable that you are given. This equation can also be written as I is equals to peak current sine 2 pi f t. Remember we discussed it before, right, in the previous slide. Okay, so these two equations, they are the same. So what you are not going to do is that you are asked to find the frequency of the current. So this is the wave equation for the current, and this is the wave equation for current too. So what you're going to do is to compare these two equations. So as I said before, and if you look at the previous examples that I solved, you will see that comparing these two equations the peak value of this current is what? The peak value of this current is equals to IO, which is equals to 30 amp. That's what we have here. Okay, so this is the peak value of the current. Okay, so from here now I've just even solved the number 2 part of it, right? Okay, fine. So for us to find the frequency, we are going to compare the two. So if we compare these two equations, you will have that 100 pi t is equals to 2 pi f t. Okay, so you cancel this out, you cancel this out. So you're going to have 100 is equals to 2f. So your f will be equals to 100 over 2, and that gives us what? 50 hertz. So this is the frequency of this current. Okay, so this is the frequency of this current. I hope this one is clear and you understand it. So having gotten you're getting the frequency, we've gotten the p value of the current from here. So what is remaining is the root mean square value of the current. Now remember that root mean square value of current is equals to this all over square root 2. Okay, or 0.71 multiplied by the peak value. Alright, so once you have this equation with you, you can solve. So this, we know the peak value, so this is 0.71 multiplied by 30. So if you work this out, you are going to have 21.3 amps. Press that from your calculator. So this gives us the root mean square value of the current. So this is your number 3. Okay, so this is the solution to this particular question. So you can see that the questions are not really that difficult, but you really need to understand them, right? So this is peak value of current, and this is where you relate the two equations together to get your frequency, and then you use this equation to get your root mean square value of the current. I hope this is clear and this is understood. Okay, so this is another question. I just decided to solve some more questions so that you can have a better understanding, really. Okay, so this question says that the current through a resistor in a circuit or in an AC circuit is given by this equation. Determine the DC equivalent of this current. Now the DC equivalent of a current is the root mean square value of the current. If you go back to where we defined root mean square value of current, it is the DC value of the current. Okay, so you can go back there and see that definition. All right, so here this is the equation that you have been given. You have been given 2 sine WT. Okay, so we are given that the current is equals to this. So from this particular equation, you find out that your peak value of your current is equals to what? It's equals to 2. It's equals to 2 amp. So that one is clear from this particular question. Here they are asking you to find the DC equivalent. So what you are looking for is the root mean square value. Root mean square value. And this is given to us as this all over root 2. Right? It's a jam question. So you can write that. You can find root 2. If you cannot, just that multiplied by IO. which has been given to you. So this will be 0.71 multiplied by 2. So by the time you work that out, what are you going to have? If you work that out, you have 1.42 as the case may be. So this will give you the DC equivalent of that current, right? So but also you can still solve it from there. You can find the square root of 2, you will have the same answer. Say IO, that is 2 all over square root 2. You know that is this is a solid equation, right? So this is a solid equation. If you rationalize this, you are going to have 2 root 2. You are going to have 2 root 2 all over 2. Okay, so this gives you root 2. So you can find the value of root 2. If you find the value of root 2, you're going to have 1.41 as the case may be. So if you look at the values, they are almost the same. This 1.4 and this 1.4. So you can use any of this method to solve it. The same thing, you have the same answer. Alright guys, so I think this is clear and it's understood, and I hope you are following. Okay, so this is your test your understanding page. I want you to solve these ones. These are simple. Please calculate the peak voltage of a main supply of root mean square value of this. So you are be given the root mean square value of the voltage. You are asked to find the VO, which is the peak value. So I think that should be easy for you. This one, if an AC is represented by this, calculate the instantaneous value of such a current if in a circuit it has a root mean square value of 15 amp when its phase angle is 30 degrees. Okay, so you see this equation, this is your peak value. So, and you are given the root mean square value of the current to be this. So what you need to do is first of all find the peak value, then substitute into this equation, and then you have your instantaneous value of your current. Okay, so I hope that is clear. Alright, so this is how you go about this question. Then in a circuit, in an AC circuit, the peak value of the voltage is 180 volt. What is the instantaneous PD when it has reached 1/8 of a circle? Okay, so here you know that a circle is equals to what? 360 degrees. So 1/8 of 360 degrees equals to what? You should know that, right? Then you are given the peak value of the voltage area. So you are asked to find the instantaneous voltage, which is like this one. So you go back to that equation and then you can solve this one easily, right? So guys, thank you so much for your time. We appreciate you, and this is where we are ending this particular segment of this class, this introduction to AC circuit, right? So please, if you have not subscribed to our channel, what are you waiting for? Subscribe to our channel. We're almost concluding the physics curriculum. Subscribe to our channel so that we'll continue to give you quality lectures. This is Normal Science Just Online. If you have any challenge, please reach us via the WhatsApp number that is showing right on your screen. Give us a positive comment, give us a like, give us a thumbs up, invite your friends to come and enjoy what you are enjoying. Is that okay? So thank you so much guys. We hope to see you in our next video. Have a nice day and enjoy yourself. Thanks.